Okay, Algebros, we have worked this whole year to get to this place where we're solving systems of equations. Last time we looked at solving systems by graphing. We took two equations and where they crossed over, they had one shared solution. Of course, the only equation that wouldn't happen that with is if it was parallel lines because they never touch, right? So if they have the same slope, it will never happen. But as long as they don't have the same slope, you know they will have one shared solution. So let's look about this a bit differently. If I have a $20 bill, that's the same as 4 $5 bills, right? They look totally different, but they have the same value, right? Same value. Or I could have a $20 bill and have it be 2 10s. Same value, right? All four things have the same value. That means I know that $20 equals $20. And I could substitute any value for that $20. Like I could substitute 4 5s and that would be equal to 2 10s, correct? Even though they look totally different because I know their value. Well, when I'm given a system of equations, it tells me that they have one shared value. They have something in common, right? So that means, with that little bracket there, that y, it says y equals y, just like the $20 bill equaled the $20 bill. And so I can substitute any of the values in for the other. Because y equals 2x, the other y also equals 2x. So to solve for this, I can say 2x equals x plus 5. And now, because I only have one variable, I can solve this system. I can subtract x from both sides and get x equals 5. Once I know what x equals, I can now solve for the y. Because it says that y equals 2x. So that means that x is 5 and 2 times 5 is 10. So the one shared solution would be the point 5, 10. Let's look at it again. If I'm told that this is a system, I know I can solve for one, substituting, and then I can then substitute that answer in to solve for the other. Let's take a look at this one. I have x plus 4y equals 6 and x plus y equals 3. Well, how do I solve for this? Well, I can just choose to solve for one of the variables. I'm going to solve here for x and get x equals negative 4y plus 6. Now that I know that x value, I can plug it into the other equation. Getting negative 4y plus 6 plus y equals 3. One variable, now I can solve for it, combining my like terms first, then isolating my y using my inverse operations. And I get y is 1. Now I can solve for x because I already know what x equals, right? I could say x plus y equals 3 and substitute there. X plus 1 equals 3 and solve. Or I could have solved on this equation right here because it already told me what x equals and just say that it equals negative 4 times 1 plus 6 would also equal 2, right? Because this always has to be the same. If I graph these really quickly, and let's just say I solve for the equations, and I graph for them, you would see that they would have the shared solution as 2, 1. Go ahead and you try this. Substitute one for the other, please. Pause your video and then check your solutions. Okay, let's see how we did. Did you get -2, 1? I hope so. Let's see how this works with word problems. One high-speed internet provider has set up a $50 fee plus $30 per month. And the other has no setup fee, just $40 per month. In how many months will the providers cost the same or be equal to each other, right? So we're going to go ahead and write equations, letting T represent the total amount paid and M represent the month. So I know my first equation is that $30 a month plus $50 initial fee, and my second equation is just $40 a month. Now because T is the same variable here, I can set these two equations to equal each other. 40M equals 30M plus 50. Now I can solve, isolating my variables. I'm hoping that you're starting to see the power in algebraic equations, that you can solve for things that you'd be like, what? I'm not sure. Let's guess and check. No more guessing and checking. You can know. Now you know the value of M, you can plug it in and solve for the value of T. So in 5 months, it'll cost $200. Yep, that's when they will be the same. Okay, what happens if you have to use the distributive property? Let's just make sure we take care of all of our bases. So first I need to solve for one of these variables if I'm just going to solve by substituting. This is the easiest one, so I'm just going to add 4y. So I get this, x equals 4y plus 11. I plug that back into the first equation for x. So I get 4y minus 5 times all of that x, which is 4y plus 11. And now I have to I have to distribute. And now I can isolate by combining my like terms first and using inverse operations and solve. And I get y is -4. Now the second part's really easy because I just can plug into either of the equations, right? I'm just going to plug into this one, the first one, and I can solve for x. And now we have our one shared solution with these two equations. Let's try it here. Go ahead, you try this one and see how you do. Pause the video and then see how you did. So we're doing 2 times that x value, combining your like terms and isolating y, and you get 3. Now it's really simple. The first one says x equals 7 minus 2y. So you just plug in the y value and solve for the shared solution would be 1, 3. Go ahead and try this one and check your solutions. Again, we have to distribute on this one. And then we substitute in to solve for y. Hopefully you also got -1/6. Let's look at another application. It says the perimeter of a rectangle is 56 centimeters. What's perimeter? Well, the distance around something, and this happens to be a rectangle. The perimeter is 56. I know that's 2 lengths plus 2 widths, or 2 lengths, 2L plus 2W equals 56. Then it tells me that the length is 4 more than 3 times the width. Well, 4 more plus 4 than 3 times the width. Now I can substitute that in for my L. 2 times that plus 2W equals 56. I distribute, combine my like terms, and isolate my variable. And I could take this complicated problem and solve so easily that the width is 6, go back and plug it into the length equation, getting 22. And you can check it. 2 22s plus 2 6s is indeed 56. All right, stay tuned because we're also going to be solving using elimination.